This is number 11 from the chapter 3 practice AP questions in the book. The slope of the line tangent, the recurring theme, you should all know that that is the derivative of the function. So we want how fast y changes as x changes. And just to make some connections, that's rise and that's run. Change up and down, change left and right. But here's the problem. We don't have y equals. So when we take the derivative, this is implicit differentiation. So I'm going to actually rewrite this above so I can work with it better. Xy cubed minus x cubed y equals 6. And this, I'm going to move to the side. That's our goal. So we have a product rule. Two things are being multiplied. And the other thing, every y is a function. Because x is our variable, y is a function. You have to realize which ones are functions, which ones are variables, especially when we get to related rates, but that's going to be later. So product rule, leave the first alone, take the derivative of the second. Well, what's the derivative of box cubed? It's going to be 3 box squared times derivative of box. But the derivative of y is dy dx. That's just a definition. Plus the derivative first, the derivative of x is 1, leave the second alone, and we get y cubed. I'm going to scoot that over because I'm seeing space issues already. Minus, and I have another product rule. Two things are being multiplied here. So in parentheses, be careful because you are subtracting everything after that. If you don't use parentheses, you're going to get an error. Algebra organization. Leave the first alone, and the derivative of y is just dy dx. Plus, take the derivative of the first, which is 3x squared, leave the second alone, and the 6 is a constant, derivative of that is 0. Now, I lied to you slightly. Here's what they actually wanted, not just dy dx. They wanted dy dx at a specific point. So let me get more detail here. They want it at the point where xy equals 1, 2. That's what they want. Now, here's a secret. I don't know if you remember. If they give you an actual point, at this point, I would not solve for dy dx. I would just plug in the points first. It makes your solving for dy dx a lot easier. So for every x, I'm going to put a 1, and every y, I'm going to put a 2. Now let's do some simplifying. 4, it's 12. 8 dy dx plus 6. I'm now going to distribute the negative sign. I'm going to combine these two to get 2. What is my goal? My goal is to solve for dy dx. So I want to get rid of this 2. I'm going to subtract 2 from both sides. Now at this point, technically you're factoring out the dy dx. In algebra, you factor out the common dy dx, you're left with 12 minus 1. So you end up with 11 dy dx is negative 2. Divide both sides by 11. Dy dx is negative 2 over 11. Now, do you have to show this step? I don't require that, because if you have 12 of them and you take away one of them, obviously you have 11 of them, but that's what you're actually doing. Negative 2 over 11, hopefully the answer appears, or I'm a sad person. It's there, and it is the correct answer.